Today is something we're going to talk about quadratic functions, things that you've already dealt with. So we're going to define the three forms of the quadratic functions. We're going to find the vertex and intercepts of a quadratic function and sketch its graph. And we're going to convert one form of a quadratic function to another. So the good news is that this is stuff that you have seen before. So what are the three forms of the quadratic functions? Well, there is the quadratic form. Actually, you know what? Before I talk about that, let's talk about a parabola. There are some things you need to know about a parabola. A parabola can open up, a parabola can open down, right? A parabola can open up, a parabola can open down. Sometimes it has a maximum, sometimes it has a minimum. If it opens down, it is a maximum value. If it opens up, it is a minimum value. And that maximum minimum, this guy right here is called the vertex. And you should know that. That's the vertex, right? That's the highest or lowest point that it ever is going to reach. Sometimes parabolas can have these guys right here. These guys right here are the x-intercepts. Sometimes they can have one x-intercept. Sometimes they can have two x-intercepts. Sometimes they can have no x-intercepts. One thing that is always true as well is that there is one y-intercept on the parabola. It always crosses through the vertex. And another thing you need to know about is that every parabola has symmetry. There is the axis of symmetry, but goes straight through the vertex. Hopefully you recall that from a previous math course. Now, the other thing is the three forms. You got the transformation form, also known as the vertex form. You know that as f of x equals a times x minus h quantity squared plus k. There's the polynomial form, which you know it as the standard form, ax squared plus bx plus c. And then there's one really cool one called the X-intercept form, which is technically the factored form. And you know that you've never seen that one, but they call that the a times the x minus s times the x minus t. That's basically if you factored it. All right. So you might want to fill in the blanks here of the three forms. The vertex of the transformation form, that one is just h comma k. In vertex form, that is h comma k. If you want a shortcut on how to find the x-intercepts if it's in transformation form and you do not have a calculator, it is h plus or minus the square root of negative k all over a. If you need the y-intercept, you can find the y-intercept from a times h squared plus k. You get that? And this works in vertex form, which is f of x equals a times x minus h squared plus k. So you don't really need a graphing calculator at all for that. The next version is the polynomial version, and you know that guy is f of x equals ax squared plus bx plus c. And I hope you're sketch noting some of this stuff, I mean, so it's not so crazy. But the vertex here, this is actually pretty cool. The vertex here, this is negative b all over 2a. And to find the y, that is the opposite of negative b squared minus 4ac all over 4a. I know that looks goofy. It's green eggs and ham, but it works. To find the x-intercepts, you're going to do the quadratic formula. I'm just going to put QF right there. You're going to do the quadratic formula. And when you're looking at ax squared plus bx plus c, whatever the value of c is, well, ladies and gentlemen, that is your y-intercept. All right. The third form, which is the x-intercept form, is found by, you call this guy the f of x equals a times x minus s times x minus t. All right. And the way to find the vertex, you just do this. This is pretty crazy. To find the vertex, it is just s plus t all over 2. And then you find f of that s plus t all over 2. what do I mean by that is if you found s plus t over 2 to be 3, you input that into the function and then see what happens. All right. So whatever that s plus t over 2 is, you input that in for x, and then boom, you're good to go. All right. The x-intercepts are just s and t. And how do you find the y-intercept? You take a and you times it by s and you times it by t. So this is just like a time saver. All right. So what am I going to do? I am going to in this video, I'm going to actually show you the x-intercept one because that's probably one that you've never, ever, ever, ever done. And then the other stuff we'll probably do in class. So let's look at one that involves the x-intercept. All right. So if we had something like this, if we had a function like f of x equals -2 times x minus 3 times x plus 1. All right. I want to find the vertex, the x and the y-intercepts for all of that. So the way to do that, looking at this, the x-intercepts. Well, the x-intercepts are actually x equals 3 and x equals -1. Well, where'd the -1 come from? Because in the generic form, this is a minus, if that makes sense. The y-intercept. The y-intercept, according to our formula, is it's a times s times t. So what that's going to be is 2 times 3 times -1. That gets me a y-intercept of, I'm sorry, -2 times 3 times -1. That gets me a y-intercept of +6. Okay? Now the vertex. The vertex, according to our formula, the vertex is found by taking s plus t and you divide it by 2. So we take s, which is 3, plus a -1 and you divide it by 2. What's 3 plus a -1? Well, that is a -2. And -2 over 2, that's -1. So the vertex is -1. How do I find the other part of it? I take -1 and I plug it into the function. So I go f of -1 is equal to -2 times -1 minus 3 times -1 plus 1. And I believe that should get you, let's see. Oh wait, that's a +1. So I'm going to plug in the +1, not -1. Silly guy. All right, so then that's -2 times -2 times 2. So that is, well, that is +8. So your vertex is at 1, 8. So now you can sketch this. Right here you go, vertex to 1, 8, 1, 1, 2, 3, 4, 5, 6, 7, 8. You can put a dot right here. You got a y-intercept of 6, 1, 2, 3, 4, 5, 6. Put a dot there. You got an x-intercept at -1 and 1, 2, 3. And connect all those and you have a pretty accurate graph of this polynomial. Pretty easy, right? Cool. Another one you've seen, this guy. Well, what form is this in? This guy is actually in vertex form or transformation form. And what I want to do here is I can actually find the vertex. The vertex is at, for this guy, the vertex is at +2 and a 5, if that makes sense. All right. The x-intercepts, according to your chart, to find the x-intercepts, when it's in vertex form, the x-intercepts are calculated by taking h plus or minus the square root of -k all over a. So here we're going to do h. h is 2. So we're going to go 2 plus or minus the square root of -5 over -4. All right, so this is 2 plus or minus the square root of 5/4. Now, what does that become? That becomes 2 plus and minus radical 5 all over 2. Those are my goofy x-intercepts. That's okay. What's my y-intercept? Well, the y-intercept, all you got to do for the y-intercept is just do this formula right here. Just do for y-intercept, you are going to do ah squared plus k. So what's A? A is -4. H is 2, so you're going to square 2, and you're going to add 5 to it. So that's -16 plus 5. So I believe that gets you a -11 is your y-intercept. Okay, so then the last thing I think you need, no, we have everything we need now. So now we just go ahead and plug in what we need. And you can graph it. But realistically, you already know that the vertex is at 1, 2, and then 1, 2, 3, 4, 5. You put that right there. And then it crosses at -11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It crosses there. You can do something like that, if that makes sense. Okay, we will talk about some of the other things in class. I just wanted to get these two guys out of the way because it's familiar. All right, so I will see you in class soon, and may the force be with you.